Okay, so one more kind of housekeeping item on ANOVAs, and then next we're going to do some problems from start to finish, from data all the way through to this last step. So this lecture is about journal format. So anytime you read a journal article where someone has done any sort of statistical analysis, there is a standard way of writing up the results of the analysis. And this is true no matter what kind of analysis you're doing. So it's true if you're doing an ANOVA, if you're doing a correlation, if you're doing a chi-square, if you're doing any one of the dozens of possible analyses that you could do. So we're going to learn how to do this for each one of our analyses, and we're going to start with the ANOVA. So the rule for how you put together a journal format is you start with the letter F, which is basically, and this is true no matter what journal format you're doing, this first thing here tells you what the analysis is. So for ANOVAs, we calculate an F ratio. So you're going to start with the letter F. In parentheses, you're going to put degrees of freedom. Now, the degrees of freedom that you're going to put here are the same ones that you used when you looked up critical Fs on the critical F chart. So for the one-way ANOVA, it's going to be degrees of freedom A and degrees of freedom S over A. But the rule is it's degrees of freedom for the numerator and the denominator of the F ratio, the top and the bottom of the F ratio. So we've got F, we've got degrees of freedom for the numerator and the denominator. They're separated by a comma. Then we put an equal sign, and after the equal sign, we're going to fill in the value of our observed F. And then after that, we're going to put a comma, and one of three things can show up after that. We're going to have something dealing with P. So we're either going to say P is less than or equal to 0.05, P equals some exact value of P, or P is greater than 0.05. So what we put in there is going to depend on the results of our significance test. So if we rejected our null hypothesis, we're going to say P less than or equal to 0.05. If we failed to reject our null hypothesis, we're going to say P is greater than 0.05. And if we did this on a computer where we know the exact value of P, we might say P equals and then fill in the exact value of P. All right, so I'm going to talk a little bit about I'm going to talk about this idea of P in a moment, but let's do a couple of examples here. So going back to our noise and memory example. Again, F, degrees of freedom numerator, comma, degrees of freedom denominator equals observed F, comma, and then something about the p-value. So for noise and memory, going back to our ANOVA summary table, this is the data from that analysis. F, parentheses, 1, 8. Those were our degrees of freedom A and degrees of freedom S over A. So F, parentheses, 1, 8 equals 35.71. This was our observed or our calculated F. We put a comma. We rejected the null hypothesis, so it's going to be P less than or equal to 0.05. Tanning and happiness, again, go back to the ANOVA summary table. F, parentheses, 2, 9, those were the 2 degrees of freedom that we used to look up the critical F, equals 29.4, that was our observed F, comma, P is less than or equal to 0.05. All right, so like I said, we're going to do a few examples from start to finish where we're going to get a chance to practice this, but this is basically always going to be the rule moving forward for journal format. You start with the letter of the analysis that you're doing, you put your degrees of freedom in parentheses, after the equal sign you put the value that you calculated for that statistic, and then after that you're going to put P is less than or equal to 0.05, P is greater than 0.05, or P equals something. So just one last thing about P. So there's something called a p-value, there's something called significance, and there's something called alpha. And sometimes these terms may seem interchangeable, so I just kind of want to clear up what's meant by the difference between these terms. When we have a 5% chance of error, all right, a 5% chance of error, that's the same thing as saying alpha. I guess it's kind of hard to see here. That's the same thing as saying alpha equals 0.05. That's 5% chance of error means alpha equals 0.05. So a 1% chance of error means alpha equals 0.01. When we do things by hand, we typically talk about that 5% chance of error, we talk about alpha, and we talk about p in general terms, like p greater than 0.05 or p less than or equal to 0.05. But when we do analysis on a computer, and you're going to have a chance to do some of these analysis on the computer using Vassar Stats, and you can also use SPSS, there's lots of programs you can use to do this analysis. When you do it on the computer, you're not getting a theoretical sampling distribution of F, where you're charting a critical value and an observed value. The computer actually does all the work for you and ends up giving you an exact value of P. So when you do it on the computer, you're going to get an exact value of P. So you might get something, for example, that says P equals 0.002. If you get something like that, when you're doing journal format, you can actually plug in the exact value of P. You don't have to say less than or equal to, greater than, you can actually plug in the exact value of P. And just to make sure you understand how this works, if you got a P of 0.002, do you think that's a reject or a fail to reject? Compare the value of 0.002 to 0.05. Is it less than or equal to 0.05 or greater than 0.05? 0.002 is less than 0.05. So if we got a 0.002, what do you think our decision is going to be? It's going to be reject. Let's say instead we got a P, let's say we got a P of 0.09. Here, let me redo that. Let's say we got a P of 0.09. Is that greater than 0.05? Less than 0.05. 0.09 is greater than 0.05. So if we calculated that on the computer, if we got a 0.09 p-value, that means we are going to be failing to reject. All right, so whole lot of information this week. Lots of evaluating, lots of comparing, lots of new terms. If you are feeling a little bit overwhelmed, just take a deep breath. This is one of those things like independent and dependent variable that we are going to be practicing over and over and over and over again all semester. So if you can't really figure out in your mind how it all connects, don't worry. We are going to have plenty of opportunity to put this all together from start to finish, and it eventually will all click.